Searching is a very common thing to do in programming, and in this project I'm going to have you write code to perform two different kinds of searches. The first search, you've done this already actually, is a sequential search. Now a sequential search is just like what it sounds like it is. You start at the beginning of the list and you go all the way through to the end looking for the item. So this is obviously going to be some kind of for loop. You're going to check each item, and if you find it, I'd like you to return the index, the position of that item, and if it's not in the list, you're going to return -1. So if I run this right now, I'm looking for above in my word list. Now you might recognize this word list from the game of Hangman. There's a lot of words in there. If I run it, I'm looking for above, and it's taken a while. Oh, found it, position 133, and actually I'm going to scroll down and see if in fact that is there, and there it is at position 133. Sequential searches are pretty slow. Let's try the binary search to look for above. Boom. Wow, that was quick. We're going to talk about what a binary search does. And actually, if I look for something even farther down the list, I'll look for pizza. That's going to take forever. I mean, it's checking each item one at a time. Oh my God, I can't wait that long. I'm going to stop this. Let's try pizza in a binary search and see how long that takes. Wow, binary searches are fast. That was really quick. All right, hang in there. I'm going to talk about a binary search. All right, let's talk about the binary search algorithm. A couple of things before we get started. I made myself a much shorter list just because it's going to be easier to show how this works on a list that's less than 58,000 items or however many items I had in the other list. And the other thing is your list must be sorted. A binary search only works if your list is in sorted order. Here my list is in alphabetical order. That's what I mean by sorted. It wouldn't work if my list was all mixed up. A sequential search would work if the list was not sorted. So that's maybe one advantage of a sequential search, but they do take a very long time. And the other thing to keep in mind is that when you compare words alphabetically like this, using greater than, less than, which you're going to have to do, less than means closer to the beginning of the alphabet. So if I run this, you can see apple less than orange. Yeah, that's true. Apple comes before orange. Apple greater than orange. Well, that's obviously false. We already said apple comes first alphabetically. All right, let's get into the algorithm. You're going to need to make 3 variables. Now, I named my variable min, middle, and max. You don't have to do that, but I think it makes sense. Min is going to be the index of the starting position of your list. So min is equal to 1 at the beginning. Max is just what it sounds like. It's going to be the end of your list, so 10 in this case. And middle is just the average of these two rounded down. Sometimes they refer to that as truncated, right? The average of 1 and 10, 1 plus 10 is 11, divided by 2 is 5.5, rounded down is 5. So that's my minimum. This process to search for a word is going to keep repeating until you either find the word or the max and min pointers cross each other. And I'll show you what I mean by that in just a minute. So here in this example, I'm looking for mango, and you say, hey, is mango equal to the thing in the middle? No, it's greater than the middle. So I'm going to move my min pointer 1 past. Wow, I just eliminated half my list. How do you like that? All right, now I recalculate my average. Well, the average of 6 and 10 is 8, right? 16 divided by 2 is 8. So I'm going to move my middle to 8. And then I just say again, is the thing that I'm looking for, remember I'm looking for mango, is it greater or less or equal to the middle here? It's less than the middle, so guess what? I'm going to move my maximum 1 past the middle. You always want to move 1 past. And then I recalculate my average. 6 plus 7 is 13, divided by 2 rounded down is 6. So I move my middle 1 past, or rather I move my middle to the new average. And yeah, right, which is 6. Great. Is the thing that I'm looking for at position 6? No, it's greater than 6. So I have to move my min 1 past the middle. Now this is going to get a little strange. It's pointing to the same location as the max. And I'll recalculate my middle. 7 plus 7 is 14, divided by 2 is 7. So now I move my middle to 7. And hey, my middle is equal to what I'm looking for is mango, and I return position 7. All right, I'm going to do one more example where the word that you're looking for is not found. Now let's see what happens if the word that you're looking for is not in your list. So here I'm looking for pizza in foods. Now I'd like you to return -1 if it's not there. And in fact, this does return -1. So let's see what happens. Now, when you do your binary search, you're going to keep repeating until the word that you're looking for is either at the middle or until the maximum and minimum pointers cross each other. In other words, until the max is less than the min, right? Right now, the max is greater than the min. All right, I'm looking for pizza. Is it at the middle? No, it's greater than the middle. So I'm going to move my min 1 past. And now I recalculate my middle. 16 divided by 2 is 8. So I'm going to move that guy to 8 right there. And now I say, is pizza at the middle? No, it's greater than the middle. So I'm going to move my min 1 past. Recalculate my middle. Let's see, that's 19 divided by 2 is 9.5, but I round down to 9. All right. Move it right there. So now my middle and min, it always gets a little funny when you're pointing to the same thing, but my middle and min are pointing to the same thing. Is my middle pointing to the word that I'm looking for? Pizza? No, pizza is greater than pineapple. I'm losing track of what I'm doing. So I have to move my min 1 past the middle, right there. And now I have to recalculate my middle, which of course is going to be 10. Now this is all going to be a little weird. Everybody's pointing to the same spot. Is strawberry the word that I'm looking for? No, it's pizza, which is less than strawberry. So I have to move my max 1 past the middle. Uh-oh. My min and max have just crossed each other, right? My min is right there. I know this is a little bit confusing at the end, but that is my stopping condition. I know that I'm done if my max and min ever cross each other. In other words, my max is less than my min. Hey, the word's not there. You are done. It's a little bit of a tricky algorithm. I think you can handle it. All right. Good luck. Thanks for watching.